All right, cool. Right, I just want to kind of quickly talk about what the plan is for today's lesson. I forgot to put it on my board, but it's pretty short and sweet. So what I want to do for today's lesson is I want to unpack an NCEA organic chemistry question with you guys. Two reasons for it. First reason is because I want you guys to have exposure to what the organic exam questions look like, because in a couple of weeks you guys are going to decide whether or not you want to do organic or thermo or both, or if you want to drop them both and just do the level 3 general science course instead, which is internal based. So that was the first reason why I wanted to kind of show you guys what these exam questions are like. It's very different from the other exam. That's the other reason why I want to show it to you guys. So if you guys remember last year with structure and bonding, it was a lot of content and a lot of writing and then math. The organic chemistry has far less writing. It is more conceptual, big picture, kind of like puzzle-like as an exam. Personally, I think organic chemistry is easier to get the excellence on, but harder to get the achieved on. So you'll see what I mean when we go through an exam question. So that's the plan for today. I have adapted these exam questions to just focus on structural isomers, which is what we talked about in our previous lesson. There are other isomers like geometric and stereoisomers, but I will cover that when we actually do our organic topic properly. The structural isomers you need to know for spec anyway, so that's why I'm covering that. So I have adopted some of these questions. We are basically starting kind of number 2 on the checklist, so just kind of keep that in mind. The other thing I wanted to kind of state with why I want to do these exam questions and first, before we go on to spec, is that the thinking involved in these organic exam questions is very similar to the merit and excellence requirements for the spec internal. So that was the kind of other thought process that I had with this. So it doesn't hurt to start doing these questions now because it will prepare you for spec anyway. So that was kind of the thought process that I had. So with that in mind, the idea was I was going to go through one of these questions with you so you can see how to work your way through it. And then you guys work on the other collated questions from it. Sound good? All right, so I'm just going to move that, if you guys don't mind, so that way we can actually start the question. So here, like I said, is the collated isomer questions. I have, like I told you, adapted them so that way it is just structural isomer questions. And like I said, really useful stuff to help prepare you for the spec internal anyway. So one of the things you have to keep in mind with the spec internal is that I'm going to give you some data, and from that data, you need to figure out what the molecule is. If you're just aiming for an achieved on this assessment, all you need to do is tell me what the spec data tells me. If you want a merit, you actually have to figure out the molecule. And if you want an excellence, you have to eliminate what the molecule is not. So basically, understanding what other isomers could be possible and why does the data tell us that it's not that one. Don't worry, we will work through some of those examples, but that's kind of the thought process. With these NCEA questions, it's kind of a similar setup where they give you some information and you're trying to figure out what the molecule is based on the hints they've given you. So similar structure, but different setup. In this case, the NCEA exam questions is going to use something called identification tests, which is why I've given you this sheet here. It's a summary of how we can identify organic molecules. Or sorry, I should say how we identify functional groups in organic molecules. When it comes to the spec internal, you will have data instead, but similar idea, trying to figure out what the molecule is. So I will use this to help us answer the question that we have here. Keep in mind that you will not get this as one of your resources on the organic exam, so you do need to memorize these tests. But for now, and what we're doing, it's fine that you use this resource as you're working. Cool? All right, so let's look at this question and unpack it. So there's several bits of different information here. I'm just grabbing a pen. All right, so this is from the 2021 exam, so last year. It was question number 1, part B. And what they've given us is a formula And this here is the molecular formula. So basically that tells us how many carbons are there, how many hydrogens are there, and how many oxygens are there. Now, if you guys remember when we talked about structural isomers last lesson, there are lots of different ways that we can manipulate the molecule to be different, but still have the same number of carbons, hydrogens, and whatever else is in there. So there's lots of different options of molecules that can have that formula, but structurally be different. So what this question is asking for is, can you figure out what molecule we're hinting at based on the information we've given you? So they have given you 1, 2, 3, 4 different molecules that you're trying to identify that have this formula, and they're giving you hints on what characteristics they have in order to figure out that molecule. So the first one here, when we are decoding that question, it says a straight chain molecule is the first hint. What does straight chain mean to you guys? Straight. Do you think it has any branches? No. So this hint tells me no branches. So whatever molecule I come up with shouldn't have any branches. The next hint it tells me is that it will form bubbles when reacted with sodium carbonate. So sodium carbonate bubbles. This is where I'm saying you need to memorize all the identification tests. Don't need to do it at this point. Instead, we're going to use our resource sheet. So on this resource sheet here, there's lots of various different information that can help me figure out what that means as a functional group. So what I am looking for is going to be, just trying to see if I can find it faster. All right, so what I'm looking for is anything that gives me information about sodium carbonate or carbonates as an identification. So what I can see at the bottom here is, or the other thing to look for is bubbles. So I see bubbles of gas produced in an addition reaction, produced on addition of reactive metal, carbonate, or hydrogen carbonate. So in this example, we talked about sodium carbonate. So this is a positive reaction, and what that tells me is that that first molecule must be a carboxylic acid. I'm being lazy and just running CA. Do you see how I've used the resource sheet to identify the molecule? All right. Carboxylic acid. I'm just being lazy. Do you want me to actually write that down? Oh, it's right here. Carboxylic acid. All right, and that carboxylic acid is the one with the carbonyl, the C double bond O, and the OH. Cool. All right, so if I go back to this sheet here, this is a positive reaction, so that tells me that that's a carboxylic acid. Now, I find with organic questions, it's really good to annotate it because it helps me then unpack what hints they're giving me. So from that 2 bits of information and the formula, I can figure out what that molecule is. So I should be putting down, I'm going to move over to this sheet here. Five carbons, 1, 2, 3, 4, 5, meets the requirement of a straight chain, forms bubbles, so I need to put a carboxylic acid down. So I do C double bond O, OH, and then I fill in my hydrogens. CH3, CH2, CH2, CH2. So what I have for answer number 1 is that I have pentanoic acid. And if I want, I can double check to make sure I have the right molecule. I'm going to count up my my carbons, 1, 2, 3, 4, 5. That's C5. I'm going to count up my hydrogens. That's 3, 4, 5, 6, 7, 8, 9, 10. And then my oxygens, 1, 2. So that matches the formula that I've been given and the conditions that the question states. So that's our first one. Keep going. Okay. So second question here is now we have a branched chain molecule. So that tells me what? There's some sort of offshoot. There are two different functional groups in that. So I have to be mindful that there are two different ones. So I don't have a carboxylic acid anymore, is what that's telling me. They cannot react with the permanganate or the sodium carbonate. So that hint tells me if it's a negative result, then that it's not a carboxylic acid. Huh? Yeah. So two different functional groups tells me it's not a carboxylic acid, because if I had a carboxylic acid, that's only one functional group. I'll talk about the permanganate and what that tells me, but we know that the carbonate tells me whether or not a carboxylic acid's there, and since it says that it cannot react with it, that tells me I don't have a carboxylic acid. So two hints in there tell me not a carboxylic acid. Are we okay with that so far? Okay. So let's see what this permanganate tells me. So if I look on this sheet, I'm looking for anything that tells me permanganate, and I see that permanganate's right over here. Permanganate is an identification test, and basically I would expect it to go from purple to colorless. In this case, it told me that it's negative for that. The permanganate test can tell me multiple things. The first thing that it can tell me is if I have a primary or secondary alcohol, so one of these two things, or a aldehyde, which is over here. So basically it's telling me it's not an alcohol that's on the first carbon and it's not an alcohol on the second carbon. It's also telling me that it's not an aldehyde. So do you see how I'm kind of pulling the information from there? Okay. So we know it's not an aldehyde. And we know that it's not a primary or secondary alcohol. So now we got to work our way through our various choices on how we figure that out. Keep going. This one, I believe, does have multiple answers. So long as your molecule fits the conditions of the statement, you're fine. All right, so when I'm looking at this, one of the things I will look as a hint is I'll check the ratio between carbon and hydrogen, because that can tell me whether or not there's a double bond present. That double bond could be an alkene, it could also be a carbonyl. What I'm looking for is basically the number of carbons if I times that by 2 and I add 2, that should be the number of hydrogens. If I have that ratio, that tells me that there's no double bond. If, however, my ratio is for every 1 carbon, I have 2 hydrogens, then that tells me that there is a double bond. So when I look at this ratio, I see that there's 5 carbons. How many hydrogens do I have? 10. So that's times 2. So that tells me there's a double bond here. If it was 12 hydrogens, then there would be no double bond. Do you see how I'm pulling that information out? Are we okay? Do you want me to write that down? Okay. So when I look at this ratio, I'll just write it in for question 2. If you have 1 carbon is equal to 2 hydrogens, and that's the ratio that you have, should actually show it as a ratio, then you have a double bond. If you have 1 carbon and your ratio is 2 hydrogens plus 2, then you don't have a double bond. Sorry, let me fix that. So in this formula, we had 5 carbons and we have 10 hydrogens. So that is the number times 2. So that tells us that we have a double bond somewhere in the molecule. It could be like an alkene, it could be a carbonyl. Those are both examples of stuff with double bonds. If I had 5 carbons and 12 hydrogens, then that's the number times 2 plus 2. So this would have no double bond. So in this example, I had 5 and 10. So this tells me that the molecule does have a double bond somewhere. So from what I can tell from this molecule, it does have a double bond. It has branches. This is what I know. It has a double bond. It doesn't have an aldehyde. It doesn't have a primary or secondary alcohol, and it has branches, or has a branch. Maybe multiple. Are we good so far? Lots of molecules will fit this condition, so I'm just going to give you like one example. So first thing that I'm thinking about when I look at this molecule is that if it's not a straight chain, my longest chain could be 4. So I'm just going to work with 4. Are you guys okay with that? So 1, 2, 3, 4. And what that tells me then is that I have 1 more carbon as a methyl branch somewhere. I know I have a double bond. Something that can do a double bond that isn't going to react with permanganate is going to be a ketone. So I'm going to use a ketone in this example. Do you guys understand how I made that jump? So a ketone can give me a double bonded oxygen. So that makes the double bond requirement. It also uses up one of the oxygens for me. It also says to me that it is not a primary or secondary alcohol. It could still be a tertiary alcohol. So what I'm going to do is I'm going to put the alcohol down and I'm going to put the methyl on that same carbon, because now it's tertiary. Do you guys remember what I was primary, secondary, and tertiary? Okay. So that meets that condition there. Not an aldehyde, has a branch. And let's fill in the hydrogens. So that's CH3, that one has 1, 2, 3, 4, so nothing else there. That one has 1, 2, 3, 4, nothing else there, and that's CH3. So that's my molecule that I'm proposing. The last thing I will double check is, does it meet the formula requirements? So I have 1, 2, 3, 4, 5 carbons. For the hydrogens, I have 3 and 3, that's 6. Did I make a mistake somewhere? Oh yeah, no, 3, 6, 9, 10. So that's right. And then oxygens, I have 2. So that meets that requirement there. So that molecule is fine. So that's how I figured out the second one. You see what I'm saying? It's kind of like a puzzle. You either like it or you don't like it. That's what I find. All right. Number 3, I'm not giving you guys to do because we haven't covered esters, so we're not worrying about what that molecule is at this point. And then number 4, let's unpack this one. So this one is a straight chain molecule again. So again, what does that tell me? No branches. It can decolorize bromine water. So that is a hint for me to try to figure out what that functional group is. That's a positive identification. So let's look at our resource sheet, and we're looking for bromine. There we go. Here we go. Rapidly decolorizes in bromine water. So it'll go from orange to colorless. That's what decolorize means. You lose the color. So that there tells me unsaturated molecule. It has a alkene as the functional group. So that's what that hint tells me. We good so far? Okay. Cool. The next thing says that it can react with dichromate, resulting in an organic product that will not form a red-brown solution when heated with Benedict's. So there's lots of things to unpack there. It's also giving you a second product, and so we have to be mindful of what that second product is doing. So first thing is we're looking at the dichromate, and we see that dichromate's here. And with the dichromate, it can react with primary and secondary alcohols. It can also react with aldehydes. So what this tells me is that since this is a positive result, it could be a primary or secondary alcohol or an aldehyde. Are we good so far? Okay. When it does react with that, the product of it does not react with Benedict's solution. So we have the first product, the original one. This is the molecule we're trying to solve. The second, and then there's like a third step. So what they're telling us is that this second step here doesn't do the next step in the reaction. So what I need to know is, what does Benedict's solution tell me? So when I look here for Benedict's solution, let's see if I can find you. Hopefully they have it on there. Oh, they don't have it on here. They only have Fellings. We'll put Benedict's solution on here too. So Benedict's falls under here with Fellings. They do the same thing. They both turn brick red. They start blue and they turn red for positive results. So it's the same. And what that tells me is that I do have an aldehyde and I don't. Like if it does react, we have an aldehyde. If it doesn't react, we have a ketone. But that's what that tells me. So what that says here is that product number 2 is not an aldehyde. So if I backtrack and I think about what the first molecule is originally, remember that, I don't know if I talked to you guys about this actually. No, I haven't. Okay, let me talk about it. So when I do this oxidation step with a primary alcohol, what I will do is I will remove a hydrogen and I will make a double bond with the oxygen. Because this is a primary alcohol, when it gets oxidized, it forms aldehydes. So I'll write that down. When oxidized, it forms aldehyde. The secondary alcohol, when oxidized, forms ketones, because if I was to put a double bond on this carbon with the oxygen, that's now a ketone, because it's not on carbon number 1. So we'll put that note. When oxidized, forms a ketone. And then when I do the tertiary one will not oxidize. And that's because it cannot form a double bond with the oxygen. So this step here tells me it's not an aldehyde. So what that tells me is that the first product is not a primary alcohol. So I ruled out this one as an option. I've also ruled out from this test here that I don't have an aldehyde because I've already used my double bond. So that guy's out. So what that tells me then is I must be dealing with a secondary alcohol. Now I just got to figure out a molecule that looks like that. So looking at my list for number 4, my knowns about this molecule is that it's straight chained, so it has no branches. I know it's a C double bond C, and I know it's a secondary alcohol. So again, start drawing something out. So I know it's 1, 2, 3, 4, 5, straight chain. I need to make sure my alcohol is not on carbon number 1 because it's secondary. So I can put it over here like that. And then I just need to stick my double bond somewhere. So it can be like over here. So fill in the hydrogen, CH3, that would be, I think, CH, 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 and that should be CH3, if I'm doing my math right. Yeah. And again, double check the number, 1, 2, 3, 4, 5 carbons. Hydrogens, 3, 4, 5, 6, 7, 8, 9, 10, and then oxygens. Oh, I made a mistake. Where's my other oxygen? Oh, one of those needs to be, we can change any of them. We can change this guy. No, it still works. I just forgot the other oxygen. That works. So you see, that's why you double check your work. So that molecule fits my requirements. I wouldn't put this alcohol on carbon number 1 because then I do have a primary and I know I can't have primary alcohol. There's lots of different choices you guys could have that would still be an acceptable answer. You could write 1, 2, 3, 4, 5. You could have the alcohols like that and the double bond over here. And that still meets the requirements of the molecule. Doesn't matter which one you write down, so long as it meets the requirements. Okay? So that's what we're talking about with isomers. So when you guys are doing the spec internal, there's a different way that you're going to figure out what the molecule is, but it's the same sort of process. You need to use the hints that are given to you to figure out what the molecule is. The excellence component of the spec internal is tell me what it's not. So like you have 2 possible answers. With the spec data, you'll be able to tell me which of these 2 are the right answer. So it's training you for spec even though it's not the spec internal. Are we okay with that so far? All right, so that answers that question from 2021. What I do want to show you guys is the marking schedule for the organic chemistry so you can kind of see what I'm talking about. So let's pull up the marking scheme for organic, and this was question number, the question we were just doing. So you can see that we got the first answer correct. Second answer we've done, and that one's also correct. Third one we didn't do. And then fourth one, you see how that is one of the possible answers. It says OH group can also be on carbon 2, 3, or 2 and 4. So do you see what I'm saying? Like there's multiple molecules that would be considered the right answer. All right, you're either gonna love or hate this. Now, with this assessment, the achieve criteria is you can get an achieve point for one structural formula correct. So if you got that first one correct, for example, or any of those four, if you got them correct. The second thing that you could have done to get an achieve point is correct function groups present on at least 2 structural molecules. Really worthwhile to annotate the question because the exam marker can use that as evidence of you identifying the functional groups. So that's what you need to do for the achieve points. For the merit, you need to get 2 out of the 3 molecules, 2 out of the 4 molecules correct. So any of these 2. And then for the excellence, you need to get 3 out of 4 correct. And we've currently got 3 out of 4 correct anyway. What I have here is all you need for an excellence. There is no justification that you need to write. You don't need to explain any of your thought process. You just need to figure out what these molecules are. So easy for an excellence if you know what you're doing because it's just all processing and puzzle solving. Really hard for it to achieve if you have no idea what's going on. So keep that in mind. Like I said, this is what to kind of expect with it. A lot of people like organic because it's just so long as they understand the process, there's not a lot of writing, and it's very easy to get your points. All right, so the other ones that I have on the sheet is 2019, and then there's a couple on the back as well. The answers are linked on the document, but do keep in mind that the answers might vary slightly from yours because I did adapt this to fit what we've covered so far. And that's basically it. What questions do you have? Yeah, I had to go back quite far to find questions because a lot of them had optical isomers, and we're not covering that until after we do spec. Questions, concerns, comments? No? All right, let me check how much time we have left.